This video is about Module 4, Lesson 23. In this lesson, we're talking about the differences between random assignment and random selection. And we're also talking about how random assignment and random selection influence the conclusions that you can make from a study. Let's get started. So we are in Lesson 23 of Engage New York Module 4. And the topic is experiments and the role of random assignment. And we also talk about comparing that with random selection. So we're asked to look at two studies. One is an observational study, and the other is an experiment. Okay, here's the first study. Study A new dog food specifically designed for older dogs has been developed. A veterinarian wants to test this new food against another dog food currently on the market to see if it improves dogs' health. 30 older dogs were randomly assigned to either the new food group or the current food group. After they were fed the new or current food for 6 months, their improvement in health was rated. So my question to you is this an observational study or an experiment? Okay, was anything done to change what was normal for these dogs? Okay, the answer is yes. They either had the same food, or I guess this current on the market food, whether it's what they had before, or the new food. So that was a change from normal, and so this is an experiment. Okay, study B. Study B is the administration at a large school wanted to determine if there was a difference in the mean or average number of text messages sent by 9th grade students and 11th grade students during a day. Students in a random sample of 30 9th grade students were asked how many text messages they sent per day. Students in another random sample of 30 11th grade students were asked how many text messages they sent per day. The difference in the mean number of text messages per day was determined. So is this an observational study, or is it an experiment? Does something different from normal happen for these students? And the answer is yes. Did something different from normal happen for these students, or did they carry on with their business or life as usual? This is an observational study. Because the administration just observed what was happening. They just asked. It's actually more like a survey. They just asked how many text messages and didn't try to influence or impose any kind of treatment. Okay. Now, which study is the experiment? And explain. Well, we just kind of did this, but my full answer is that study A is an experiment. The treatment variable was dog food type, and the response variable was health rating. Okay, and there was a difference from the norm. In your own words, describe what a subject is in an experiment. Well, a subject is the person or the place or the thing that receives the treatment. Okay, it can be people, it can be dogs, it can be plots of land. So those are the things that are receiving the treatment. Okay, what in your own words described what a response variable is in an experiment? Well, a response variable is what is measured to see if the response to see the response from the treatment. Okay, so it's what's happening as a result of your treatment variable. Okay, and this is not controlled by the experimenter. Okay, the next question is, in your own words, describe what a treatment is in an experiment. Well, in my own words, a treatment is the condition or conditions to which subjects are randomly assigned by the experimenter. Okay, in our dog food study, it was, this food on the market or the new food hopefully is better for dogs. Okay, it's whatever is assigned, whatever conditions are assigned, and that could be nothing different from normal, or it can be a different treatment. Okay. All right, let's talk about random selection and random assignment. Take another look at the two studies described above. We just looked at those. Study A, the dog food study, is an experiment. We got it right. While study B, text messages, is an observational study. We got that one right as well. The term random sample implies that a sample was randomly selected from a population. The terms random selection and random assignment have very different meanings. Random selection refers to randomly selecting a sample from a population. Random selection allows generalization to a population and is used in well-designed observational studies. So let me pause there for a second. So if you randomly select a sample from a population, then that allows you to be able to draw your conclusion about the entire population, not just the sample that you studied. Okay, and we'll look at that a little bit later with the text messaging. Okay, what we can conclude from that. Okay, now another piece is sometimes, but not always, the subjects in an experiment are also randomly selected. Okay, and that also influences the kind of conclusion you can make, and we'll see that as we go on. Okay, random assignment refers to randomly assigning the subjects in an experiment to treatments. Okay, so random selection is most often used in observational studies, and random assignment is most often used in experiments. Random assignments allows for cause and effect conclusions and is used in well-designed experiments. Okay, so in study B, the text message study, data was collected from two random samples of students. So the question is, can the results, let me go up a little bit. Can the results of the study be generalized to all 9th grade and all 11th grade students at the school? Why or why not? Okay, well, the answer is, was it randomly selected? And the answer was yes. The results can be generalized to all 9th or 10th graders at this school because the sample was randomly selected from this school. Okay. Suppose there really is a difference in the mean number of texts sent by 9th grade students and 11th grade students. Can we say the grade level of students caused the difference in the mean number of texts sent? Why or why not? Okay, can we say that that the grade level caused the difference in the mean number of texts? Well, the answer is no, we cannot, because this is an observational study. Caused the difference in average text because this was an observational study, not an experiment. We can only say that there appears to be a relationship. That kind of got cut off there. Okay, there's some kind of something going on there, but we cannot say that grade level is causing that difference. Okay, one more thing I want to point out here that's not kind of brought up in the questions is that can we if there really is a difference, at this school between 9th grade, our random sample of 9th graders and a random sample of 11th graders, can we conclude that nationwide all 9th graders send fewer text messages than all 11th graders? The answer is no. Okay, this was randomly selected from the school, and so our conclusion is still limited to just the school. Okay, but if this is true that there was a difference in our sample, that we can conclude that at this school, there appears to be a relationship between text messages and grade level, but we can't say one caused the other. Okay, going back to study A about dog food, suppose that the dogs were fed the new food showed improved health. Can we say that the new food is the cause of the improvement in the dog's health? Now, hopefully you're getting to the point where you're like very careful about the word cause. Now, is this an experiment or an observational study? Okay, the dog food study, study A, was an experiment. Okay, and it was subjects were randomly assigned, so the answer is yes. We can say the new food is the cause of the improvement because the dogs were randomly assigned to treatments. Okay, hopefully the only main difference between group A and group B, or the group that got the on the market normal food and the group that got the new food, hopefully the only difference there is the food they were eating. And so we can say, yeah, that the improved health is because of the new dog food. Okay, and we can say this because it was randomly assigned. The next question is, can the results of the dog food study be generalized to all dogs? To all older dogs? Why or why not? Okay, can you generalize this to all dogs? And the answer is no, you can't, because only older dogs were used in the study. But can you generalize this for all older dogs? Well, the answer is no. The results cannot be generalized to all or even all older dogs because the dogs were not randomly selected from the population of all old dogs or all dogs in general. Okay, so we can't really generalize this to all dogs or even all older dogs. So that is a limitation from this study. But generally speaking, I believe that that this was a pretty well designed study, and we probably can conclude that older dogs would benefit from this new health food if we saw a difference. Okay. I now want to go down here at number 9 and look at each of these and say, for the table below, the table below summarizes the differences between the terms random selection and random assignment. For each statement, put a check mark in the appropriate column or columns and explain your choices. Okay, so which are used in experiments? Well, definitely random assignment is used in experiments. Now, can random selection be used? The answer is sometimes. Okay, if it is used, then we can generalize to the entire population. So sometimes it's used in experiments. Which is used in observational studies? Well, random selection is. It's not random assignment because I'm not assigning any kind of treatment. Which allows generalization to the population? Well, random selection. If you use random selection, you can then generalize to the entire population. Okay, which allows cause and effect conclusion? Well, that happens in experiments which use random assignment. Page 170 and 171 are your homework for this week. And I don't want to do those because that's your homework, but I do want to bring up one idea that's not touched on yet in this video. And I'll use problem 1 on page 172 in your module book to kind of bring out that point. Okay, a botanist was interested in determining the effects of watering either 3 days a week or daily on the heat rating of jalapeno peppers. The botanist wanted to know which watering schedule would produce the highest heat rating in the peppers. He concluded the experiment. Page 170 and 171 are your homework for this week. So I'm not going to do any of those problems because that's your homework, but I do want to bring out one idea that's not touched on yet in this video, and I'm going to use problem 1 on page 172 to do that. A botanist was selected in determining the effects of watering either 3 days a week or daily on the heat rating of jalapeno peppers. The botanist wanted to know which watering schedule would produce the highest heat rating in the peppers. He conducted the experiment randomly assigning each watering schedule to half of 12 plots that had similar soil and full sun. The average final heat rating for the peppers grown in each plot was recorded at the end of the growing season. Okay. Now the thing I want to point out is, how do you randomly assign, half of the 12 plots? Okay. Humans are very bad at generating random numbers or doing things randomly. You may think, well, I'll just do things crazy or, just do it without a reason. But humans have been shown to be very, very bad at randomly making assignments. Okay. And so we turn to random number generators to really randomly assign things. Okay. There is a feature on your calculator to do this, but a really nice way to do it for this is random.org/sequences. I'm going to go there. This is random.org /sequences, and this is a random sequence generator. Now, we can on our calculator generate random numbers, but they might be repeats. So a sequence is where I take a certain number, sequence of numbers, and I rearrange those numbers but not repeating any, which is really useful. Okay. In our question about the botanist and the jalapeno peppers, I have 12 plots. I'm going to go from 1 to 12. Okay. And I'm going to put it in one column. Actually, I guess I can go in two columns because I want two different groups, one to get 3 days a week and one to get daily. Now, before I hit get sequence, I'm going to already decide, so there's no bias, that the left column will be my 3 days a week. Okay, I've already pre-numbered my 12 little plots. Okay, and the left ones will be the 3 days a week ones, and the right ones will be daily. I'll decide that before I randomly select these. Okay, I will now hit get sequence. Boom. Okay, so I ran this random number generator told me that plots 4, 8, 1, 6, 9, and 3 will receive the the 3 days a week watering schedule, and plots 11, 7, 2, 5, 10, and 12 will receive daily watering treatments. Okay, that was randomly generated, and so that's my random selection. Okay, I do want to finish this question. The subjects are the 12 plots of jalapeno peppers with similar soil and full sun. Okay, the treatments are the watering schedules, okay, either 3 days a week or daily. And the response variable, what we're measuring at the end for this one, is the average final heat rating for the peppers. This video was about random assignment and random selection, what those are, and also how those influence the conclusions that you make from a study. Thank you for watching.